Welcome to today's session. Today, MicroID presents hardware for front-end developers. But first, let's talk about hardware. For this session, we selected few hardwares currently MicroID have for communication. Not forgetting our main hardware, access control, which consists door control, barrier control, and in version 2, lift control. In version 1, the device will work with our local backend. And also with limitation, it will work with our cloud backend. In version 2, it will be improvements of the version 1. On our next hardware, we have many relays acts as an output. Relay board. This board has inbuilt instructions. There are more than 20 instructions to control the relay. We've listed few here by grouping them as normal board and lift board. The board's extra feature, on power failure, it retains the previous relay condition when power on. Moving on to our next board, switch board. This time it's all inputs. The board has 10 inputs and 2 of it can be used as ADC. Extra feature in this board, it can support wireless remote. This board is still on development stage. By next year beginning, around January or February should be released. Our next board is surprisingly our most demanded board, IO board. It's a combination of a relay board and switch board. With 4 inputs and 5 outputs, the board is able to do many things, such as standalone panic button with SOS and fire function, push button for door control, with combination of alarm output. Other things that it can do is standalone 2-door interlock with push button to it, standalone 4-door interlock, plus software control basic input-output. It also can monitor of panic buttons of interlock. Specialty of this board for interlock function, by adding few IO boards, you can use for more than 4 doors. Last but not least, our communication board. This communication board supports RS485, Ethernet and Wi-Fi. RS485 and Ethernet is still in development and should be available by the mid of next year. Right now this board is Wi-Fi ready and supports MQTT protocol. Therefore this board also can be said IoT ready. Okay, we have covered all the hardwares. Now for the front end. Front end is the software interface where the user interact with. The interface can consist of mobile app, PC software or web app. Most of the time, users never cared about the hardware, but what the interface can do for them, such as map, charts, reports, hardware details, and many more other things that the software can provide. Users also want their interface be simple and helps to reduce their workload as well. Now, the question is, how front end communicates with hardware? In our conventional method, the method most of our software works. We have front end requests hardware for information. The hardware processes it and replies. This process is done one at a time. Due to the hardware limitation, this will be too slow. This problem we have known for a long time and solved it with a good software developer. So every software developer needs to know communication protocol and methods for each hardware. Not only that, manage multitasking. For example, the program doesn't seem hang when downloading. While downloading data, we can do other activities. It makes the program more responsive. So how are new program developers going to cope up with these issues in a short time? While building a front end very responsive, simple, fast, interactive. Now let's look into how our current front end developers work. Normally the front end guys interact directly to a remote database. Their request and reply happens nearly instantly. Now the developers can concentrate more on designs, content delivery, user-friendly and responsive software without worrying any type of limitations that can hinder their development. Now let's go back to the conventional method. How do we solve this problem for the developers? Simple. We build the backend server for them. After working with few web developers and app developers, building hardware related software, backend server was the solution we came up to. To the front-end guys, we provide them the REST API, WebSocket, webhook, and the data in JSON format. And all the hardware related things, we handle them, such as socket handling, communication handling, all the hardware drivers, that means all the hardware's protocol, we handle them. Because this backend is a server, we are able to host it in a cloud and make this as a cloud server as well. Now the front end can communicate via internet and the hardware becomes an IoT device. With this infrastructure, we have a system that we can work locally as well as in the cloud. Long story short, we have a backend server for our hardware. With this, we solve the problem where developers need to know protocols, communications, or hardware. We don't need a very experienced developers now. Conventional method is now no more. Now, where does this bring us to? We just made possible for hardware to current front-end developers. Conclusion. Who benefits from this backend? We can say the backend is for full front-end developers, customization projects, integrators of software or hardware, automation, hobbyists and students. Now for our demo. Let's turn our hardware into IoT and use our backend cloud. We will get the communication board, set up its Wi-Fi, add it to our relay board, switch board, and IO board. That's it. We'll go for the demo. Thank you.